at the same time. Here we have a scale drawing of the Earth with the moon 240,000 miles away. This is the elliptical path which our rocket ship will follow, going out and coming back. For the rocket to leave the orbit of the space station, its speed will have to be increased by firing the rocket for a brief period of 10 minutes. The ship will then coast for 5 days. The Earth's gravity begins to slow the rocket down until 121 hours later, at a point within 60 miles of the moon's surface, it will begin to fall back toward the Earth. Gradually picking up speed, it will take another 5 days to coast back to the space station. This model will show you how our future moon rocket ship might be designed. It will be 53 feet in length, has no wings or tail surfaces, because it will be assembled and operated only in the vacuum of space. For the hull of the ship, we are adapting the cabin section of one of the Earth to space station passenger rockets. To the nose, we have added a small atomic reactor, which will drive a steam turbine and furnish electricity for the ship's instruments. This shield will protect the crew members from dangerous radiation. The ship's crew of 4 men will be placed 2 in the front and 2 back here. This is the directional radio radar antenna. Located underneath is the airlock for a spacesuit. The suit can be entered from inside the ship. Clustered around the rear of the ship are the 7 extra fuel tanks filled with hydrazine and nitric acid. All but the centrally located tank will be released when empty near the end of the return trip to cut down on dead weight. Even though we now have the theoretical knowledge to make a trip to the moon, it will be many years yet before our plans can fully materialize. However, let us imagine for a moment that the many problems have been solved and that after completing our space station, we are ready to begin our first voyage around the moon.
Ladies and gentlemen, through a worldwide network of radio and television, we are bringing you an on-the-spot account of the first expedition around the moon. Here at Space Station number 1, 1,000 miles above the Earth, the final preparations have all been made. Except for the time the rocket is on the other side of the moon, our radio and that of the station will be in constant communication with the ship during the 10-day voyage. As the moon ship stands by, the all-important pressurized spacesuit enters the rocket's airlock for the last time. During the trip, it'll be used only in the case of emergency. The captain is the last man to come aboard. He will direct the entire expedition from his position at the front of the ship. The navigator, with his specialized instruments, is responsible for plotting the unmarked path through space. The radio operator must maintain constant communication with the Earth on the space station. Finally, the rocket ship's motor and other mechanical functions will be the responsibility of the engineer. After final instrument check, the ship's crew lock themselves in position for the blastoff. Now, only minutes remain until firing time. The captain sets the automatic firing timer and reports to the space station.
RM1 to Station 1, firing timer is engaged. We will begin power maneuver for departure in exactly 16 hours, 23 minutes, 47 seconds.
Roger, RM1, 16 hours, 23 minutes, 47 seconds, over.
Crew will secure and stand by for firing in 84 seconds. Acknowledge. Navigator, check. Radio okay. Engineer, check. Motor pressure 447 psi, 3 low. Turbo pump 11,000 RPM, right on the button. Actuator steady. Guidance readings okay. Cabin pressure 0.3 psi low. Cabin temperature 72 degrees. Over.
This is Station 1 calling RM1. Our radar telescopes have charted your firing time and course. Give us a voice report for instrument error check. Over.
Well, we're on our way. Joe, how about another report?
Our firing time was 10 minutes, 0.35 seconds. Cutoff velocity, 21,888 miles per hour. Cutoff altitude, 1,765.2 miles. 1.6 low.
Okay. Now let's double check that star tracker with an optical and radar fix.
Right.
Captain, position check shows 0.7 miles below, 1.2 miles left, and 0.3 miles ahead of standard flight path. We have only a 0.03% error in azimuth reading.
Sounds good. Bill, let's transmit all your tape reports to the station.
Gentlemen, we are interrupting our program to give you the following message. Moonship RM1, which left the space station a little over 51 hours ago, reports a distance of 169,000 miles from the Earth. The ship is traveling at 9,400 miles per hour, and deviations from the intended flight path have been so small that the captain reports no corrective power maneuver has been necessary as yet. We are happy to report all the crew are in good condition.
Check the console, Joe. Try to pick it up. Bill, is your electrical system working?
Emergency condition. Repeat. Verify. Over.
Meteor hit, number 2 nitric acid tank. Pressure's dropping fast.
It's number 2, all right. Joe, put the air blowers on emergency power. Frank, get in the bottle suit and patch that hole. Don't use your motors near that leak. Try to reach it with the gripping arms.
Station 1 to RM1. Station 1 to RM1. Our instruments indicate emergency condition. Verify. Repeat. Verify. Over.
RM1 calling Station 1.
This is Station 1. Go ahead.
At 51 hours, 22 minutes elapsed flight time, registered hit by a small meteor. Puncture between Station 51 and 52, upper bulkhead of nitric acid tank number 2. Repairs are underway. RM1 to Station 1.
This is Station 1. Go ahead.
Meteor puncture sealed. Estimated diameter of meteor, 1/16 of an inch. No injuries, equipment okay. Estimated loss, 180 gallons of nitric acid. Proceeding on flight plan. Over and out. Station 1, this is RM1. At At 110 hours, we are beginning measurements at rim of the moon for accurate position fixes. We are now picking up the unknown side of the moon. Bill, give me an altitude reading.
Okay. Radio altimeter reads 22,886 miles from the moon's surface.
Oh, we're moving in fast. Frank, have you got anything in that star occultation reading yet?
Just a moment, I'll run it through the computer. Captain, we're approaching the moon on ellipse 29. Course indicates collision with moon at 1:20 hours, 56 minutes. Correction tape 340 must be used at 1:16 hours.
As the 116th hour approaches, the navigator must act quickly to avoid a collision with the moon. He starts the tape selector, which will automatically correct the rocket's course by firing the motors for a precise number of seconds.
RM1 to Station 1. At 116 hours, conducting power maneuver on correction tape 340. Out.
Captain, we're almost on the button. We'll pass the moon surface at 63 miles instead of 60.
Close enough. We'll make the correction on our return maneuver. Joe, set the spatial attitude control to keep us lined up with the flight path tangent. Stand by for observation schedule 17.
Station 1 to RM1. We acknowledge observation schedule 17. Checklist as follows. Green filter 93-B on electronic camera on upper astrodome. Use magnetic color tape on station 3, lower astrodome. Run 180-degree graph through contour mapper, over.
The next few hours will constitute the most important phase of the trip. The moon is sweeping past the ship at great speed, and in the brief span of about 3 hours, all close-up observations of its unknown surface must be completed.
RM1 to Station 1. We are now seeing the Earth disappear behind the moon's rim. This will be our last radio message until you see us on the other side.
Roger, RM1. Good luck.
I see what looks like a tremendous crater ahead. Bill, what does the contour mapper indicate?
Depth of crater is beyond range of contour mapper.
We'll reach the day and night terminator in 5 minutes. Frank, arm your flares and stand by to fire when I give the signal. Okay, Frank. Fire your flares at 3-minute intervals.